Good morning, guys. So today for discrete math, what we're going to start analyzing, different types of symmetries. We're also going to be analyzing polygons as a whole, their properties, different factors of sides and angles of polygons, right? So that's what we're going to be working with today, just analyzing properties of polygons, because after we analyze the properties of different polygons today, we're going to be applying properties of symmetry for the next couple of lessons and analyzing polygons as a whole, right? So what we're going to start today, again, we're just going to be looking at properties of polygons, right? And when we're hearing the word polygons, some people are thinking, what is that? All polygons are, guys, are just different types of figures. Now, the main definition of a polygon, and this is the most important thing about a polygon is a geometric figure with sides and angles, right? With sides and angles. And so there's so many, guys, a lot that you know, a lot that you don't know. Let's look at a few examples, right? So if we're talking about polygons, we know that polygons that we know of, the most basic one that we know of is a triangle, right? So we know that we have a triangle. We know a lot of you would say this is a rectangle, but again, we have triangles, we have quadrilaterals, we have other ones that we're going to go into, right? All of these different types of polygons. That would be a pentagon. All of this we're about to go over in a few minutes. All of these, we know that there are different polygons, triangles, quadrilaterals, pentagons, because they all have sides, they all have shapes. The one that's not a polygon, right? Not a polygon, and it's the one shape that most of the times people think is a polygon, and it's not, it's a circle. A circle is not a polygon, right? The reason why a circle is not a polygon, a circle doesn't have any sides. So since a circle doesn't have sides, can't be a polygon, right? Cannot be a polygon, has no sides. So if we have sides and angles and it's a closed figure, has to also be closed, right? Sides and angles, and must be closed. That would be a polygon. And the reason why I'm saying that, imagine drawing a triangle. Imagine drawing a figure with 3 sides that stays open. Not a polygon, right? It has to stay closed. Also, can't overlap, right? The fact that it starts overlapping and cannot overlap. And by mean overlap, again, can't go past, right? So if we're thinking about this, if we're thinking about a quadrilateral, that wouldn't be it, because again, can't overlap, right? So a polygon has to have sides and angles, has to be closed, and can't overlap, right? Can't be open, can't overlap. And again, can't have any curves, that idea of a circle, right? Needs to have sides, can't be curved. A polygon cannot be curved, just straight sides. So always remember, the most basic one that people think a lot of times is a polygon, is a circle. Circle has no sides, it's curved, can't be curved, right? Gotta have sides. So those are polygons, those are properties of polygons. And then it's just seeing different types of polygons, which you've heard of, a lot of their names. You may not necessarily know at first glance what they are based on it. A lot of you do know and have learned these already before, right? So different types of polygons. The most basic one that everybody knows all the time would be a triangle, right? And again, triangle has 3 sides, right? And all polygons are just figures based on their sides, right? We have a triangle, we have a figure that has 4 sides, right? Which a lot of people would call a rectangle, a square, all of that. Those are different types of quadrilaterals, which we're gonna go into, right? But the most basic, if it has 4 sides, it's a quadrilateral, right? And then we have something that has 5 sides, right? The one that has 5 sides, we call it a pentagon, right? Just like the building in Washington, D.C., that would be a pentagon. I'll do one more, right? And then we have a figure that has 6 sides, right? Sorry that it looks terrible, but if it has 6 sides, it would be called a hexagon. And so all of these figures, they all have names, right? And they all have names based on how many sides they have, right? So whenever we're looking at a figure with 3 sides, that polygon's a triangle. If it's got 4 sides, it's a quadrilateral. If it's got 5 sides, it's a pentagon. If it's got 6 sides, it's a hexagon. And then there are other ones that we know, right? If a polygon has 8 sides, it's an octagon. Just like a UFC ring, it's called an octagon because it's got 8 sides. We have something called a decagon, which has 10 sides, a nonagon, which has 9, a heptagon, which is the one that most people usually don't know and get wrong. A heptagon sounds like a hexagon, but what a heptagon has 7 sides. So again, all of these are based on how many sides they all have, right? But there's another way to actually refer to figures. Whereas if we have a triangle, if it's got 3 sides, we can call it a triangle. We can also even call it a threegon, right? Because it's got 3 sides. Threegon just means polygon with 3 sides. If we're talking about a pentagon, we can call it a fivegon. And it's called a fivegon because it's a polygon with 5 sides. If we're talking about something that's got 15 sides, has an official name for it, but something with 15 sides, we can call it a 15gon. It's a polygon with 15 sides. All different ways of being able to name these guys, right? So again, whenever it comes to polygons, they all have names for them. Ones that we know, other ones that we don't, but the easiest way is always to even refer them by how many sides they have, right? So those are different types of polygons. And remember, a circle is not a polygon because it has curves. There are no sides on a circle. A circle is not a polygon, right? And so whenever we're talking about polygons, right, there are a few terms that we look at to analyze. And one of them is a word that we've referred to before already in the past. So a word called isometry, right? And what isometry means is, if a figure has isometry, isometry literally means maintains congruence, right? Maintains congruence. When we're congruent, it means that they're going to be exactly the same, right? So if we're talking about 2 figures, one that has isometry, one that doesn't have isometry, right? No isometry. Sorry about the squeaking too, guys, of the marker. We know that if we were to draw 2 triangles like this, we know that these 2 here would be isometry because to the best of my ability, they're congruent, right? Same figure, same size, right? Whereas if we were talking about, let's say we're talking about 2 different quadrilaterals, we know that these 2 quadrilaterals would not have isometry because one's bigger than the other, right? Isometry means it has to be congruent, has to be the same shape, has to be the same size. If it's exactly the same, it's isometry. If they're different sizes, it's not isometry. So again, remember that. And then there are 3 terms that we need to go over which are extremely important when it comes to describing polygons, based on the size and based on the angles, right? One of them you've probably already heard of, definitely, for me at least, in terms of ways that we describe triangles, right? We have one term that we refer to as equilateral, right? We have a term that's equilateral, and all equilateral just means are all congruent sides. All congruent sides. Equilateral just means all sides are congruent, right? That's all it means. Then we have another word, and here, let me actually draw a picture for you guys to be able to actually analyze it. So when we're talking about a figure that's equilateral, it means that all the sides are congruent. So put a tick mark here, put a tick mark there, put a tick mark there, right? We know that this triangle here would be equilateral, and we know it's equilateral because all the sides are congruent, right? They all have one tick mark. If all the sides are congruent, it's equilateral, right? Then there's another term, which I don't think you guys have ever heard of, which is called equiangular. Equiangular. And all equiangular means, if you listen to the word equiangular, it means that we have all congruent angles. All congruent angles. So, If we're talking about equilateral, means that all the sides are the same, because lateral literally means sides, equi means equal, equal sides, equiangular means equal angles. So equiangular means that all the angles are congruent, right? So if I were to look at a quadrilateral, right, that's equiangular. Again, we're not saying that all the sides are congruent, we're saying that all the angles are congruent, right? So you would see curve here, you can see a curve there, curve here, curve here. Since they all have a curve each, we know that all the angles are congruent. If all the angles are congruent, equiangular. If all the sides are congruent, equilateral, right? So let's make this a polygon, no overlap, right? So equiangular means all the angles have to be the same. Equilateral means all the sides have to be the same. But then there's another word that actually ties both of these together. Sometimes you have figures where all the sides are congruent but not the angles. Other times you have situations where all the angles are congruent but not all the sides. But then there's a situation that we have where everything is congruent. All the sides are congruent, all the angles are congruent, everything about the polygon is congruent. And that word that we use to refer to is regular, right? A regular polygon. And all regular means it's exactly that. All congruent sides and angles. Everything about it's congruent, guys. All its sides, all its angles, right? Everything about it is congruent to each other. And when we're drawing that, right? And I'll draw a triangle just to have the most basic of figures to show you. If we're talking about a triangle, again, if it's regular, all the sides are going to be congruent, right? One tick mark, one tick mark, one tick mark. That would be equilateral, right? Because only the sides are the same. But the second now that I make all the angles the same, now we see all the sides are the same, all the angles are the same. Since everything is congruent, it's regular, right? That would be considered regular. It's also considered all three. Technically, it is equilateral. It is equiangular, right? It's equilateral because all the sides are the same. It's equiangular because all the angles are the same. But when we have everything the same, the best way to describe it would be regular, right? That's it, guys. Just remember, again, we're starting to analyze different polygons by their terms, ways of analyzing them. Just remember all these terms. And any questions you guys have, always feel free to ask. Take care, guys.